Good day, I'm Mr. Matthew, and I'm taking you Geometry 2. And these are the objectives that I expect you to be able to know at the end. To extend the sine, cosine, and tangent ratio as acute angle, of acute angle to obtuse and reflex angle. 2. Express positive or negative angle of any size in terms of its equivalent angles. 3. Use trigonometrical tables to determine sine, cosine, and tangent of any angle. And lastly, define sine, cosine as ratio within a unit circle. The general angle, that is the 4 quadrants, and this is the first quadrant where x and y are both positive. Here, this is the second quadrant. Y is positive, x is negative. X is negative here. The third quadrant, y is negative here, x is positive here. And the last, the fourth, x is positive, y is negative. And each of the angle, you have 90 degrees. Each of them is 90, you have 90 degrees each. Positive and negative angles. Anytime you move this way from the x-axis, you move anti-clockwise, you have a positive angle. You have a positive angle. So this angle is positive. And when you move from the x-axis in a right angle, in a clockwise direction, we say it is a negative angle. So it's very important. And move forward. Equivalent angles. We are talking about those angles that have the same value. The same value. That's what I mean by equivalent angle. Now here you have 60. You move from the positive x-axis. This is 60 degrees. Now when you move clockwise direction, you move in clockwise direction here, from here to here. See, you have minus 300 degrees. So plus 60 degrees and minus 300 degrees are equivalent. They have the same value. If you are given minus 300, it's the same thing as 60 degrees. Because when you combine them, it will be 360 degrees. The same here. We have 160. You move anti-clockwise this way. 160. Then the remaining 200, which is negative, they have the same value. Minus 200. They are equivalent. That means they are equal. They are the same. This is another equivalent angle. Equivalent angle. These 3 angles are the same. 460 degrees is the same thing as 160. That means it's having extra 160 when you move a complete circle. From here you move like this. You move this way. This is 360. Then the extra, that is 160 here. So it's the same. 400 and in a similar manner, when you move anti-clockwise this way, you can see That's minus 200. They are the same. 3 of them are the same. Similarly, these 3 are the same. 390 degrees. 390 degree. That means we have completed a 1 revolution, 360. This is 360 already, and you go extra this way. So the extra here, which is 30. So 390 degrees, the same thing as 30 degree. And then the remaining, the negative, when you move back like this, is minus 300. So these 3 angles are the same in terms of. So I want to give you examples. Which quadrant does P lies in is 150 minus 120 minus 80 minus 230 degrees, and lastly we have 305 degrees. And these are the solutions. We need to represent them. 150 is more than 90. This is the first quadrant, it's more than 90. So it's in the second quadrant. It's in the second quadrant. Second quadrant is in the second quadrant. That means P is here. It's in the second quadrant. Second one, minus 120. You know, when you want to draw minus, you move from x-axis down. So it's more than 9, it's more than minus 90. So it's in this quadrant. And this quadrant is the third quadrant. So this is in the third quadrant. The third quadrant. Very important. Is minus 80. It's less than minus 90. So here, this angle here is in the fourth quadrant. This is the fourth quadrant. So P is in the fourth quadrant. While here, as I've said earlier on, this is in the third quadrant. P is here. Then 130. 130 is more than 180. So it's in the third quadrant. 230 rather is in the third quadrant. So this is in the third quadrant. Third quadrant. This is another one. 305. 305 is less than 360, so it is more than 270. It's in the fourth quadrant. This fourth quadrant. This is P. P is here. It's in the fourth quadrant. Then we have another example. Find the positive angle between 0 degree and 360 degrees. That is equivalent to the following angles. 1, 610 degrees minus 60 degree minus 150 degree and 760 degrees. These are the solutions. These are the solutions. So, when you remove this, yes, you minus it from 180, you minus it from 360 degree, full. This should be 360 degree, 360 degree. And whatever is left, we have that. You have that one as 250 degrees. So it's 610 minus 360 degrees. And the answer is 250 degrees. B, we add one full rotation, that's one revolution, that's 360 to minus 60. we have 300. So the answer is 300. 300. 300. You can use diagram as well to get it. You can use diagram. You are here. You move 60 here. So the remaining angle here will be 300. This is 60 degree. So the remaining one is 300 degree. That's the anti-clockwise when you move anti-clockwise. Again, minus 150, you add 360 to it. Similar to that, you add 360 to minus 150, you have 210. So it's equivalent to 210 degrees. And lastly, since this is more than 2 times 360, this is 2 revolutions, which is 270 degrees. You have to remove 270 degrees from this value, and you have 40 degrees. So 760 degrees is equivalent to 40 degrees. So the answer, and these are the assignment I have for you. Exercise 17A, number 1 to number 4. New General Mathematics, SS1 on page 206. Now I want to discuss something similar to what we are doing. It's called a unit circle. You all know circle. You know a circle. What is now a unit circle? It's a circle of radius 1. The radius is 1 unit. With the equation, this is our y-axis and this is our x-axis. So the equation is of the form, when you use Pythagoras theorem here, use Pythagoras theorem, the square of x plus the square of y will equals to the hypotenuse square, which is this is the equation of that unit square, because it's in 2 dimensions, x and y. Using Pythagoras is from Pythagoras theorem, you have this equation. I hope that is very clear. Then we want to treat each quadrant now to know what to be to know which one is positive of the 3, sine, cosine, and tangent. In this is the first quadrant, if you remember, then I introduce it to you. We bring out a right angle triangle. This is our y, this is our x. This is the angle in the first quadrant, is less than 90. What we mean by it's less than 90. So we want to determine here the sine, which is opposite over 1. It is positive y over 1. That is plus y. So sine is positive in the first quadrant. Similarly, cosine, this is the adjacent over hypotenuse. So it is x over 1, and it is plus x. So cosine is positive. Lastly, what is tangent of this angle? We know that tangent is opposite over hypotenuse. Opposite y over the hypotenuse. Opposite over adjacent, sorry. So we have plus y over plus x, which is plus y over x. So tangent is positive. Means that all of them are positive here. We use A, the first quadrant, that all. The A standard, sine is positive, cosine is positive, and tangent is positive. And now move over to the second quadrant. That's the angle, obtuse angle. Angle between 180, angle between 90 and 180. It's less than 180, but more than 90. This is it. We draw the right angle triangle again. It's right angle here. So to us to get the equivalent of this theta, this angle, we have to remove it from 180. So this is the angle we are interested in. The remaining angle, the supplementary angle. The supplementary angle here. Very important. So we consider this angle. So the sine for this angle here y is positive. So it's opposite, positive, opposite over, which will give us plus y, plus y, and y cosine here, x is negative here, this x is negative, is adjacent over this is going to give us minus x. So cosine is positive, cosine is negative. And lastly, tangent, which is opposite over hypotenuse of this angle, is going to give me minus y over x. So we have sine, cos is only sine that is positive. Only sine. So we use x here. This place, we normally write it as x, capital X, meaning that it's only sine that is positive. The other two, they are both negative, as you can see there. Then we move forward. We move forward to the third quadrant. This is the third quadrant. X is negative here. Y is also negative here. So this is the angle is more than 180. We are looking for this angle is equivalent. This theta is equivalent to this angle. It always make with the horizontal, the x-axis. Very important. So let us look at the sine of this angle, cosine and tangent. This is the opposite. This is the opposite. This is the opposite. Why this is the adjacent. Now, for sine of this angle is going to be minus y. Minus y. It's minus y. So sine is negative. Y for cosine, it will be minus x over 1, which is minus x. So cosine of this angle is negative. Y sine 2 is negative. But let us see tangent. Tangent here is opposite, which is negative over adjacent negative. So negative divided by negative is positive. So we now have tan to be positive here. It's only tan that is positive. It's only tan that is positive. Now the last quadrant. This is the last quadrant. Very important. Y is negative here. This is negative y. But x is positive. So we have the remaining angle to make with the horizontal here. This is the angle we are interested in to make with the x-axis. So you remove theta from 360. So this is the angle. Very important. So we are looking for the sine of this angle, which is minus y. Minus y. So sine is negative. Let's say cosine. Cosine is adjacent. This is opposite. This is opposite. Y this is adjacent. X. X is adjacent over the hypotenuse, which is also here is positive. So cosine is positive. Then let's see tangent of this angle. The tan of this angle is opposite, that's minus y over plus x. So it's minus. So tangent is negative. So it's only cosine. We write as capital C. So the summary of everything now is this. All are positive in the first quadrant. 1. Only sine is positive in the second quadrant. Only tan is positive in the third quadrant. And lastly, only cosine is positive in the fourth quadrant. Very important. So we have cast. Cast here denotes first, we normally start with A. A stands for 1. This is 2, 3, 4. When you move from here anti-clockwise, if you want to have at, you go from here clockwise. You have arts. Very important. The cast is very popular. So I want to find the sine of the following 60, 120, 240, 300. Here we go. Sine 60, that's the first quadrant. All of them are positive. Just check from the timetable. You have this. Then for cos is 0.5, that's half. For sine 60 is 0.866. While for tan 60 is 1.732. Now, all these angles, they are all equivalent. 120 only is in the second quadrant. This is first quadrant acute angle. So only sine is positive, you see, positive. The other two negative, they will be negative of these two. Very important. Very, very important. Very important. Then the third one, this is obtuse angle. The third quadrant, this third quadrant. So sine of this, sine is negative. So that's why you're having negative of 0.8660. Cosine 2 is negative. So it's equals to minus 0.5. Or half, minus half. Only tangent is positive. You see, that's why it's having 1.732. Very important. This is the third quadrant, only tan is positive. Remember cast. The last quadrant, you see that it will be cosine that will be positive. The other two will be negative. So tangent, sine is minus 0.866, while cos of 300 is the one that is plus 0.5. And tangent of 300 is minus 1.732. So the solution, very important. And I'll be giving you this as assignments. Exercise 17B, number 1 to number 4. New General Mathematics on page 210. The last assignment is exercise 17C, number 1 to number 6. Here you will need to draw your graph. Examples are there. And I wish you the best. Have a wonderful day. Till we meet again on another topic. God bless you.